Hashing is an algorithm. Algorithm is the set of action that should be applied to some input to receive some output. Okay, so what is input and what is output? You know from the informatics that every complex data, for example, a photo, a video, some electronic signal, or even the complicated database, can be presented as a file on the disk. And every file can be presented as a sequence of bytes, and every sequence of bytes can be presented as a sequence of bits. So everything in our computer is just simple long strings of bits. 0, 1, 1, 0, 0, 0, 1, 1, etc. It's very simple. Okay, so what is hashing? Hashing is a way to take a very long input data, for example, some big file, for example, some video or a very long log file, and calculate some interesting value. This value is relatively small. Modern cryptographic hashes have a size of 256 bits. It's only the bits. It's only 64 bytes. 64 bytes. 64 bytes, you can think about it like 64 letters. It's not a very big string. But this number has a very significant properties. The most important property of hashing is a kind of a digital fingerprint of a file of arbitrary length. So if we take a file and calculate its hash, and then we'll change a single bit in the source file, and calculate hash again, we'll receive a very different hashes. It's the first property. So if we want to send to somebody a file through the network, and the file can be received with some errors here, we can pass also the hash. It's short, and the probability of errors in hash very small. So the receiver can calculate the hash by himself and check if these two hashes are equal. So it can say that he received the file without any single error. The next very important part of hashing is the inability to find a so-called collision of hash. What is collision? Collision is a situation when we have the same hash for two different files. They have the same hash. Finding the collision in the cryptographic hashing is very difficult, and for cryptographic hashing now it's simply impossible, because it requires a very large amount of computations. So, for example, if I'll tell you, okay, let's calculate the hash of this string, Smartz. I'll calculate the hash, and I can ask anybody of you to calculate the hash of any other string that has the same hash that I've presented to you. You'll be unable to do it. So you'll need to try every possible strings, and that because the amount of possible hashes is 2 in the power of 256 variants of hashing, you'll be doing it a very long time. Trust me, a very long time. With such properties, cryptographic hashing has a lot of important implementation in modern informational system. The first implementation is to use hashing the way to check the integrity of data. This is the situation I've shown you in previous variants. So when we send some data and want to check that no one bit was changed, we just calculate the hash of this data and provide it like a digital fingerprint. We don't need to publish the file. We just can publish the hash, and everybody who downloads this file can calculate this hash on its computer and be sure that he received this file without any single error in any bit of this file. This is the first implementation. Another useful implementation of hashing is hiding the sensitive data. For example, my browser wants to send the login data to a web server. This is my browser. I know my password, but I don't want that my password will go to the network as an open string. So I don't want that anybody who can access to the telecommunication equipment can sniff value of my password. So I simply send the hash of my password. It has the same string that my password, but I don't need to send this string by itself. Even the server doesn't know my password. Server knows only hash of my password. If an attacker wants to guess what is my password, he needs to take millions of passwords, password 1, password 2, password 3, calculate their hashes, and wait until he'll meet the hash like mine. It's very complicated computational task, and it's almost impossible to crack a modern cryptographic hashing. Another method to use hashing is in algorithm when we want to promise to show some value to somebody and then show the value itself. It's made to avoid the situation when somebody declines to participate in our protocol. For example, I want to send some data, some secret value to somebody, and my recipient don't want that I'll decline to show the data, this data in the future. So the first, I send him the hash of my data. Also, I can include some money that I lost if I will not present the actual data, and after some time, I present the data itself. If I don't do it, this money comes to receiver of data because he didn't receive his data. If not, the money goes to me. Of course, the most important usage of hashing in the blockchain is connecting the block. It's very widely described by many authors and other our videos, so check them out. And the next time we will continue with the digital signature.